As we start our unit on sinusoidal functions and the transformation of sinusoidal functions, we first need to know about the characteristics of a sinusoidal function. And yes, I do have a cold, in case you're wondering. So let's first of all recognize a sinusoidal function is just a generic name for a sine or a cosine function. They are the same curve, just shifted over 90 degrees. The first thing we're going to define is a sinusoidal axis, which is the horizontal line that cuts the graph in half vertically. So we're going to label this is the sinusoidal axis. Secondly, the amplitude. The amplitude is the distance from the sinusoidal axis to the high point of the graph. One cycle is the length on the x-axis, or actually one cycle of the graph is just one section of the graph that repeats itself. So once we've gone through one cycle, the graph will just repeat itself. So this is one cycle here. The period is the number of units on the x-axis that equals one cycle of the graph. And we're specifically looking here at the equation y equals sine of theta. In other words, the parent function, nothing's been done to it. We haven't changed any of its original characteristics. So the original period of a sine function is 2 pi, or 360 degrees. So the period is equal to 2 pi units in this case, because that's how long it takes to go through one cycle of the graph. The frequency equals 1 divided by the period, or 1 over 2 pi. So the period tells us how many units per cycle. So I think we'll just write that up here. The period is units per cycle. The frequency is cycles per unit. And we'll talk more about that when we get into application problems. Frequency and period will make a little more sense when we put a context to it. The phase displacement is the x-coordinate that marks the beginning of one cycle. When the graph is shifted, right now the graph starts, the beginning of the cycle is at 0. So we say the phase displacement is just 0 here, or the starting point is just 0. But if this whole graph was shifted to the left or to the right, then the phase displacement would move. So we'll look at an example where the phase displacement is moved in just a moment. Let's look down here now at the graphs that are below here. This is a cosine cycle. When we contrast this to the sine cycle that we just saw, when we describe a cycle of a cosine graph and a cycle of a sine graph, we want to look at 5 critical points. So here are my 5 critical points for the cosine cycle. Here are my 5 critical points for the sine cycle. The critical points are just points that are on the sinusoidal axis, or high points or low points. So I'm just going to call those maximum or minimum points. If you know the location of these 5 key points, then you'll be able to draw the graph. I also want you to notice that these 5 key points are equally spaced on the x-axis. So the distance on the x-axis between the key points is always the same. So these sections of the graph are dividing the entire cycle into 1/4, okay? So there's the whole cycle, there's half a cycle, there's 1/4 of a cycle. So these key points are always equally spaced in the cycle. Same thing over here for sine. That'll be useful as we start to draw the graphs. Now, what happens when we change something? So I want you to notice here that we have a curve, a sinusoidal curve, that is no longer horizontally split by the x-axis. Now the horizontal line that divides the graph in half is down here, at -2. So that is the sinusoidal axis now is at -2. Notice the amplitude is 1 still. So still the amplitude is equal to 1. I don't know exactly what I wrote when I wrote that. Why don't I just write AMP here, that for amplitude. The amplitude is equal to 1 because it still goes up 1 from the sinusoidal axis. Sinusoidal axis is now -2. Now, is this a cosine graph or a sine graph? The answer is yes, actually. It could be either one, depending on where you name the starting point. So if I wanted to name this as a cosine cycle, I would start at a high point and end at a high point, and I would say, here's a cosine cycle, and it looks like my starting point would have shifted either, it looks like about 5.5 left, or about +1/2 right. Okay, so the phase displacement is either at -5.5 or +0.5, depending on where you start. You want to say that's my starting point of my cycle. The period looks like it's about the same. If I were to take this graph and move it here, it looks like that would be still have a period of 6.28 or 2 pi. So the period doesn't look like it's changed here. Now what if I wanted to name this as a sine cycle? Well, look at a sine graph right here. It starts on the sinusoidal axis, it goes up, then down, then back up again. So starting on the sinusoidal axis right here, going up and down and back up again, that would be one sine cycle. It looks like the sine cycle starts at -1. So my phase displacement for a sine cycle would be -1, and then it still has the same amplitude and sinusoidal axis and period as the cosine graph. Now, at this point, you're going to be doing some explorations on a worksheet with sine and cosine graph, and then you're going to want to look at the video about transformations of sinusoidal functions and fill out the chart on the back of these notes.